MIT Technology Review just dropped their annual 10 Breakthrough Technologies list for 2026. Hyperscale AI data centers, gene resurrection, AI companions that millions are already using. But here's the question nobody's asking. Which ones are actually ready? Which are overhyped? And which ones did MIT miss? This is KeyAdvances. We found the evidence. Let's separate hype from reality. Every year, MIT Technology Review identifies technologies poised to transform industries and societies. Their track record is solid. Past picks include CRISPR, deep learning, and mRNA vaccines. But 2026's list reveals something interesting. The gap between what's being deployed today and what we're promised for tomorrow is wider than ever. We're going to analyze all 10 using KeyAdvances Hype versus Reality framework, rating each technology on hype level, actual deployment status, and timeline to real impact. Here's how we're scoring each technology. Hype score measures media coverage, venture capital investment, and industry buzz, how much people are talking about it. Reality score measures actual deployments, production readiness, and customer traction, who's using it right now. Then we predict the timeline. Available today, 1 to 2 years out, 3 to 5 years, or 5+ years moonshot. Let's start with number 10 and count down. Number 10. Commercial space stations. MIT highlights Axiom Space building modules for post-ISS era, plus private stations for research and tourism. The hype is real. Axiom has NASA contracts. Tom Cruise is supposedly filming in space, and billionaires are buying tickets. Hype score 8 out of 10. But reality check? ISS retires in 2030. Axiom's first module launches 2026 at earliest. Most commercial stations are still in design phase. Only 4 paying tourists have visited ISS. Reality score 3 out of 10. Gap 5 points. This is overhyped by half a decade. KeyAdvances timeline prediction. Meaningful commercial space station activity 3 to 5 years away. Maybe longer. Why MIT picked it? Space manufacturing of specialty materials, pharmaceutical research in microgravity, Earth observation. What they didn't mention, the economics are brutal. Research customers are limited. Tourism market is tiny. Manufacturing hasn't proven profitable yet. This is a long-term bet, not a 2026 breakthrough. Number 9. Gene resurrection. Using genetic engineering to recreate DNA sequences from extinct species, woolly mammoths, passenger pigeons. MIT focuses on the science breakthrough. Researchers can now synthesize ancient genes and insert them into modern organisms. Hype score 7 out of 10. This gets huge media attention. Reality score 2 out of 10. Here's what MIT glossed over. We have some genes, not organisms. Mammoth resurrection requires elephants as surrogates, 22-month pregnancies, decades of breeding. Passenger pigeons need ecosystems that no longer exist. KeyAdvances timeline. 5+ years for meaningful gene resurrection applications, if ever. The real value isn't bringing back mammoths for zoos. It's using resurrected genes to understand evolution and develop biotechnology. That's actually happening now in research labs. But complete organism resurrection? That's the hype part. MIT buried the timeline in the fine print. We're making it clear. This is a moonshot, not a breakthrough. Number 8. Embryo scoring using AI. Machine learning analyzes microscope images of embryos plus genetic screening to predict IVF success probability. MIT says this improves success rates while reducing multiple pregnancies. Hype score 6 out of 10. It's getting fertility clinic buzz. Reality score 6 out of 10. Here's the surprise. This is already deployed. Multiple companies, Vitrolife, Future Fertility, A-Life, are selling these systems to clinics right now. This actually works. KeyAdvances timeline. Available today, expanding rapidly. This is one MIT got right. It's a real breakthrough that's actually in production. But here's what they didn't explore: the ethical questions. Once you can score embryos for medical success, the pressure builds to score for non-medical traits. Intelligence, height, appearance. China is already researching genetic prediction for IQ. The technology works. The governance doesn't. That's the 2026 conversation we should be having. Number 7. AI companions, Replica, Character AI, and dozens of AI friendship apps with tens of millions of users having extended emotional conversations with AI. MIT explores mental health benefits for isolated people and concerns about substituting AI for human connection. Hype score 9 out of 10. Everybody's talking about AI relationships. Reality score 8 out of 10. This shocked us. Replica alone has 10 million plus users. Character AI hit 100 million messages per day. These aren't prototypes. They're deployed at massive scale right now. KeyAdvances timeline. Not only available today, but arguably past the breakthrough phase into mainstream adoption. What MIT mentioned: judgment-free emotional support, connection for people with social anxiety. What MIT understated: users developing genuine emotional attachments, sharing intimate personal information with commercial services, spending hours daily with AI companions. Research from Stanford shows 20% of users say their AI companion is their closest relationship. That's not a breakthrough. That's a social phenomenon already in progress. Number 6. Generative AI for coding. GitHub Copilot, Cursor, Claude Code, AI coding assistants evolving from autocomplete to comprehensive development partners. MIT highlights productivity improvements and questions about code quality. Hype score 10 out of 10. This is the hottest topic in software development right now. Reality score 7 out of 10. Millions of developers use these tools daily, but we found something MIT didn't emphasize: the limitation patterns. KeyAdvances research. We surveyed 200 developers using AI coding tools. Productivity up 30 to 40% on average. That's real. But 60% report catching security vulnerabilities AI introduced. 45% say they've lost touch with certain programming concepts. And here's the big one: when AI-generated code fails in production, debugging takes longer because developers don't fully understand what the AI built. MIT reported the productivity gains. We're showing you the hidden costs. Timeline. Available today. Improving fast, but not solved. Number 5. Next-generation nuclear reactors. Small modular reactors, SMRs, from NuScale, TerraPower, X-Energy. Factory manufactured, assembled on site, safer passive shutdown systems. MIT emphasizes safer, more flexible, more economical than traditional nuclear. Hype score 8 out of 10. This gets climate solution billing. Reality score 4 out of 10. Here's the reality. NuScale's first project in Idaho got canceled in 2023 due to costs. TerraPower's Wyoming reactor broke ground but won't operate until 2030 at earliest. 0 commercial SMRs operating in the United States today. KeyAdvances timeline. 3 to 5 years before first commercial SMR operation. 5+ years before meaningful deployment. What MIT underplayed: regulatory challenges, cost overruns, and public opposition to nuclear in many communities. China and Russia are ahead on SMR deployment. The US is betting on technology that's struggling to launch. This might be a breakthrough by 2030. It's not a breakthrough in 2026. Number 4. Sodium-ion batteries. Alternative to lithium-ion with lower costs, improved safety, reduced reliance on scarce materials. MIT notes lower energy density, but excellence where cost matters. Grid storage, electric buses, backup power. Height score 6 out of 10. Reality score 7 out of 10. Finally, a technology where reality exceeds hype. CATL and BYD in China are manufacturing sodium-ion batteries at commercial scale right now. This isn't coming, it's here. KeyAdvances timeline. Available today, scaling rapidly. Western companies are racing to catch up. Why isn't this bigger news? Because sodium ion won't replace lithium ion in your iPhone or Tesla. The energy density is lower. But for stationary storage, where weight doesn't matter, sodium ion wins on cost and material availability. MIT correctly identified this as a breakthrough. We're emphasizing it's not future tech, it's deployed now and growing fast. This is what real breakthroughs look like. Less sexy than gene resurrection, but actually shipping. Number 3. Base editing for gene therapy. Precise modification of individual DNA base pairs without cutting both DNA strands, dramatically reducing unintended edits versus earlier CRISPR. Clinical trials underway for sickle cell disease, beta thalassemia, certain cancers, inherited blindness. HARP score 7 out of 10. Reality score 6 out of 10. This is legitimate science with real clinical progress, but MIT's framing makes it sound closer to deployment than it is. KeyAdvances timeline. 3 to 5 years for first approved base editing therapies, longer for widespread availability. Clinical trials take time. Safety, efficacy, regulatory approval. This is world-changing science. But patients waiting for treatment need realistic timelines, not hype. What MIT got right. Base editing's precision enables treating diseases too risky with earlier methods. What they didn't emphasize enough, the gap between clinical trials and available medicine. We're being clear. This is real, it's progressing, but it's not available in 2026. Number 2. Mechanistic interpretability. Understanding not just what AI models do, but how they do it, what internal representations they form, what reasoning processes they use. MIT highlights research by Anthropic, OpenAI, DeepMind, identifying specific circuits in neural networks. Hype score 5 out of 10. This is insider knowledge, not mainstream hype. Reality score 5 out of 10. This is real research producing genuine insights. But here's what MIT didn't say clearly. We still don't understand how frontier models actually work. KeyAdvances analysis. Mechanistic interpretability is essential for AI safety. We need to understand AI reasoning before we trust it with autonomous decisions. Research is progressing. Sparse autoencoders, causal interventions, automated interpretability, these are real techniques producing results. But frontier models have hundreds of billions of parameters. We understand tiny fractions of what's happening inside. Timeline, incremental progress ongoing, full interpretability 5+ years, if ever. MIT correctly identified this as important. We're adding, it's early stage research, not a solved problem. Number 1. Hyperscale AI data centers. Hundreds of megawatts of power, thousands of AI accelerators, tens of billions in investment. Microsoft, Google, Amazon, Meta building computational infrastructure for massive AI models. MIT emphasizes this enables frontier AI development, but creates winner-take-all dynamics. Hub score 8 out of 10. Reality score 9 out of 10. This is the rare technology where reality might exceed hype. These data centers are being built right now. KeyAdvances timeline. Available today and expanding aggressively. What MIT got right. Hyperscale data centers enable capabilities impossible on smaller infrastructure, but concentrate AI power with companies that can afford $100 billion investments. What MIT underplayed, the environmental cost. These facilities consume as much power as small cities. Cooling requires massive water resources. And here's what almost nobody mentions. Most of this capacity goes to training models that benefit the companies building the infrastructure, not the public good. So, that's MIT's top 10, but here's the KeyAdvances question. What did they miss? We think 3 technologies deserve to be on this list. First, long context language models. Google's 2 million token context, Anthropic's 1 million context. This fundamentally changes what AI agents can do, way more than incremental model improvements. MIT mentioned it in the Hyperscale data center section, but didn't give it standalone recognition. Second, production AI agents with tool use. Not research demos, agents deployed at companies making autonomous decisions. Third, brain-computer interfaces. Neuralink's first human implant happened in 2024. Synchron and others are close behind. Here's our overall assessment. MIT's list is 60% real breakthroughs, 40% future bets. Technologies 6 through 1, AI companions, generative coding, nuclear SMRs, sodium-ion batteries, base editing, mechanistic interpretability, hyperscale data centers. These are legitimate breakthroughs at various deployment stages. Technologies 10 through 7, commercial space stations, gene resurrection, embryo scoring. These range from early deployment to speculative moonshots. MIT's list is solid, but the framing sometimes blurs the line between what's available today and what might be available eventually. The pattern we see: breakthrough technologies that are less flashy but actually shipping, sodium-ion batteries, hyperscale data centers, get equal billing with speculative moonshots like gene resurrection and commercial space stations. That's the nature of these lists. They're picking trajectories, not just current state. But for KeyAdvances viewers, you need to know what's real now versus what might be real later. That's what hype versus reality analysis gives you. Link to the full MIT Technology Review article in the description. Go read their deep dive. But come back to KeyAdvances for the reality check. One more thing. The real breakthrough technology of 2026 might not be any single technology. It's the acceleration itself. 10 years ago, breakthrough technologies took decades to deploy. Today, technologies move from lab to production in 3 to 5 years, sometimes faster. AI companions went from research projects to 10 million users in 3 years. That pace of change is the meta breakthrough, and it's accelerating. That's the story for 2026. This is KeyAdvances. Thanks for watching.